falling right down, my mind overwhelms. I think that I'm broken, but I hope you can't help. I know I'm not perfect, but some days I feel far more worthless. Baby, you make me feel nervous. If I still have you, I have purpose. It's all worth it. I know you told your friend you're not okay, and tell me what's wrong and why you not.
Alrighty, mic testing, mic testing. Okay, perfect. Let me go to my main camera. There we go. Alrighty, we're live, and as you guys can tell by title and thumbnail, today I'm going to be starting with model evaluation. Where last stream I did work with let's say skitlearn, and I have been doing that for let's say the past week or so. I think it's been like more than a week, like around 2ish weeks or so. That said, I was done with skit learning yesterday, and today is day 88, where I actually, hold on, let me check if it actually is day 88. Oh wait, it's today's day 86, and I will be working a bit with model evaluation, so let me go to my gameplay screen. There we go. Okay, and what was that intro actually? And yeah, wait, hold on, let me just grab this here real quick. I will be using, let's say, a 25 to 5 minutes is Pomodoro session as well this stream, too, where every 25 minutes I get a 5 minutes break, and every 4 sessions of 25 minutes I get a 15 minutes break. In my break, I will be playing some Wuthering Waves, because that gives me nice content. Okay, and this is a brand new closet chat, so let me say something like "since I am live!" exclamation. There we go. Oh yeah, and I will be touch tapping as well, but I'm gonna go ahead and hold on. I'm gonna go ahead and start my timer in 3, 2, 1, let's go. There we go, we're just making sure my fan is on. Okay, let me say something like "since I am live!" exclamation. There we go. Okay, let's see. And I actually did not work much with model evaluation, or haven't heard much about it either. Okay, I have sort of heard about it, but I did not really look much into it off stream. I'm gonna go ahead and let's say grab this here. Cause apparently under my model evaluations is concept, it says train/test splits and cross-validation. I don't know if this means training models, which if it is training models, by god, I won't be able to do that in my PC. I mean, maybe I could, but I'm pretty sure it's like really resource consuming if you like try to train it at home. Overfitting, underfitting. Okay, I did kind of work with that, so it's gonna be kind of easy to figure that part out. That's it. Sensei in the building. Let's go. Okay. You already know the shape of what's coming. Classic machine learning is done. Regression, classification, clustering, PCA, all of it hand verified against real output, no shortcuts taken. That's not nothing. That's the last piece before you actually start building models that get graded instead of just built, which is exactly what today is. Model evaluation of 4 pieces, train/splits and cross validation. Confusion matrices /precision/recall F1 rock curves aux and overfitting/underfitting/regularization. Oh god, how are those 4 pieces? This is clearly more than 4 pieces. Okay, this is the last block of phase 2. After this we go on into project 2. Okay, you know what, phase 2 did go by really fast. That was kind of planned as well, because phase 1 is the thing that really is supposed to take really long, because I had to get a general grasp of all the concepts that I was going to go over in all 8 phases at a very basic level, just so I could be exposed to them. That said, project 2 is going to be a real predictive model built from scratch, evaluated like you mean it, written up like you're presenting to a client. I see. We start with the first piece, train/test splits and cross-validation. Before I teach anything, straight question, no guessing. Have you ever heard of or worked with train_test_split from skit-learn, or the general idea of splitting your data before training a model? I have not. Yeah, I do not remember myself working or learning anything about this. Okay, good. Clean slate, no bad habits to unwind. Let's build it right. The first time. Here's the problem we're solving. Every model you've built so far, decision trees, random forest, ridge, SVMs, you trained it on some data. Then you asked it to predict on the same data or close to it. to check if it worked, right? Okay, then you asked you to predict on the same data. Yeah, I did do that. Here's the trap. If I hand you the answer key and if I hand you the answer key and the test and I ask you to grade yourself, you score 100 every single time, even if you didn't actually learn anything. You might just memorize question 4's answer C without understanding why. That's exactly what a model can do. Give it enough flexibility, think a deep decision tree or a high SVM from what you already know, and it can literally memorize the training data noise, quirks, coincidences, and all. Instead of learning the real underlying pattern, it'll look perfect on the data it trained. It'll look perfect on the data it trained on and then fall apart on anything new. So the fix is dead simple, and you can probably guess the shape of it. I cannot. Never let the model see the test before grading time. Okay, that does make sense. You take your full data set and you physically split it into 2 separate chunks before you train anything. A training chunk, the model learns from this, adjusts its weight / split / boundaries based on this data only. A test chunk, the model never sees this during training. It's locked away until the very end, then you ask the model to predict on it. And you grade it against the real answers. If the model does well on the test chunk, data is never seen. That's real evidence it learned from the actual pattern. Okay, not memorized answers. Quick comprehension check before we go further. If a model scores 99 accuracy on data it trained, but only 60% on the test chunk it never saw, in your own words, what does that gap tell you about the model? It has memorized a few patterns based on the data that it has been trained under. There we go, and then I'm just gonna go ahead and send it. Close, but let's sharpen it. You're circling the right idea, but the word memorize needs to be fully replaced. Learned the real pattern here, not sit next to it. Think about it this way. If it actually learned the real general pattern, that pattern would still hold true on new data, because a real pattern doesn't care whether the data points is old or new. So a huge gap, 99 versus 60, 99% versus 60%, means the opposite of learning a real pattern. It means it locked onto specifics, quirks, noises, noise, coincidences that only exist in that exact training set and not generalized. That has a name, and it's the one you already know from ridge regression. What's the term for a model that fits training data extremely well but fails to generalize new data? Wait, it said I've learned that in regression, right? Hold on. Let me grab my roadmap up here real quick. Okay, so I worked with that in regression. Linear logistic decision trees. Nope, not here. Let's go with something like, can I get a hint? Because I don't know the word. I haven't memorized the words. Fair, let's ground back up to something you already built. Remember ridge regressions? The whole motivation for ridge was a model that could develop huge extreme weights by exploiting a coincidental pattern in the training data, like a house number happening to correlate with prices. You describe the analogy yourself. A student who memorizes 20 practice questions instead of understanding the concept and then fails on the exam. What's the name of that exact problem on the ridge was built to fight? Okay, this is something I may know. Pretty sure that it was ridge regressions. It was ridge regressions. Not quite. Ridge regressions is not the fix, not the problem it's fixing. Wait, ridge regression is the fix, not the problem. Asking about the disease, not the medicine. Go back to the exact phrase you used messages ago, right before I asked this question. You already said yourself when explaining the trap of grading yourself with answers. What's the word for a model that fits its training data too well? Memorizing. Nice, okay. What does the problem start with? Like, what is the initial? I just need a tiny hint. So it starts with O. Huh. What the hell? Think about the shape of the word itself. The model is doing too much, overfitting itself into every little wrinkle in the term. Overfitting is literally the only word. That's it, overfitting. Okay, you know what? That makes sense. That makes sense now. You already knew this. It was buried in your own bridge regression work. You just needed it pulled back out. That's normal. That is exactly the reinforcement. That is exactly the reinforcement come from later applied use. Thing you've asked about a few times. This is that happening in real time. Overfitting from Ridge just got a second life into model evaluation. You guys see what I mean? Every time, the first ever time you guys learn a concept, don't focus on mastering it. You guys will be getting a lot of repetitions. As a matter of fact, in my roadmap under the model evaluation, I just worked with overfitting, but later on, I will be working with a dedicated category of overfitting and underfitting. And also regularization, which I don't really know what that is for now. But yeah, there's going to be a lot of repetition, so just focus on being exposed to topics. And while you guys work on different topics, these certain topics are going to be, let's say, being absorbed or soaked by your brains. And by the time you guys get to work it again, you guys will be having a better understanding as to what it really does. Okay, thing you've asked about a few times, this is model evaluation, and now it's stapled in twice as hard. That does make sense. So here's the full picture now, stated cleanly. Overfitting equals to model fits the training data too well, memorizes noise, coincidences, instead of the real underlining pattern, and fails to generalize to new data. The train/test splits how you catch this. A train accuracy high plus test accuracy low equals to red flag. You're looking at overfitting in the wild. Now, flip side, a quick gut check before we move to syntax. If a model scores low on both the training data and the test data, say 55% on training, 58% on test, is that overfitting? Why or why not? It is overfitting because it is overfitting. The model has memorized too much noise. From the data that it was trained on. Okay, and then let's send it. Wrong direction. This is actually a really useful mistake to catch right now because it's the mirror image of the trap you just escaped. Walk through the logic with me. Overfitting means the model does well on training because it memorized it, and poorly on test because it doesn't generalize. That's a gap between the two. High train, low test. Built in the scenario, the model is doing badly on both 55% training and 58% test. There is no gap. It's failing everywhere, including on the exact data it was trained on. Oh, wow. I didn't notice that. Hold on. So ask yourself, if it memorized the training data, shouldn't the training score be high? Why would a model that supposedly memorized too much still only score 55%? Oh, what does that tell you about what's actually going on? Oh, it is underfitting. That was a guess. That was a hypothesis. Okay, that said, I am pretty sure that underfitting is the word to use here, even though I do not know the conditions required in order to claim that it is underfitting. Okay, wait, that said, low training, I mean low score on training. Where's T? There we go. There we go. Low score on training means low data memorized. Low data memorized. Okay. Therefore, a hard time to generalize it. Okay, and then let's go with something like and a low score in test means that it could not generalize a lot of data that it has trained on. However, it would not be called, it would not be called underfitting. I mean, it would not be called overfitting. Hold on. Because the training was inaccurate as well. There is nothing much someone can do in a test if they were not prepared for it. Guys, it's so satisfying to freaking type here. Good, you landed on the right word, underfitting, and your gut instinct, a low train score equals to something's wrong even before we test it is exactly the right instinct. Let's clean out the reasoning underneath it though, because a couple of pieces are tangled. You said low score on training means low data memorized. Let's slow down on that specific phrase. Is memorization even the right lens for this scenario at all? Reread what you did with overfitting. Memorization was the explanation for a huge training score. Your training score is low. Straight question. If a model can't even score well on the data it directly trained on and had full access to the problem that it memorized too little, or is the problem something else about the model's ability to capture the pattern in the first place? It is the model's ability to capture patterns. There we go. Oh god, are you kidding me? In the first place. It is the model's inability to capture patterns in the first place. Exactly, that's the real mechanism, and it's totally different failure, and it is a totally different failure mode from overfitting. Not memorized too little, but generally too weak / simple to capture the pattern at all. Some model shapes just don't have enough flexibility to represent what's actually going on in the data. Imagine trying to draw a straight line through data that clearly curves. No matter how much training data you throw at it, a straight line can't bend to fit a curve. It's not a memorization problem, it's a capability ceiling, okay? Now, so now you've got both failure modes cleanly separated. Like, and this is like a real skill / training test. Splitting unlocks. You can now diagnose a model just by looking at the gap between two numbers. Train score, test score, diagnosis. High train score, low test score, overfitting, memorized noise, doesn't generalize. Low training score, low test score, underfitting, model too weak to capture the patterns at all. High training score, high test score, good fit, actually learned the real pattern. Okay. That table right there is basically the entire diagnostic purpose of train slash test splitting in one shot. Without the split, you'd only ever see one number, and one number can tell you which of these three situations you're in. Quick check before we move to actual code. Which of the three rows in that table is what we're aiming for every time we build a model? High train score and high test score, which is equal to a good fit. Oh god, there we go. Okay, high train score, high test score is gonna be a good fit. Then let's send it. Correct, that's the target every time. Now let's get this into real code, because the concept means nothing until you can actually execute the split. The tool is train underscore test underscore split from sklearn.model selection. Oh wow, we're using sklearn throughout this machine learning phase. From sklearn.model underscore selection, I want to import train underscore test underscore split function. Here's how it's used on a made up data set. X, 9, 12, 18, 21, 25, 30, 40, 90. And then fail, pass. Train underscore X train, X test, Y train, Y test equals to train underscore test underscore split, X, Y, test size 0.2, random state 42. Break that down piece by piece, input your full X features and Y labels, the whole data set on split. Output, 4 things come back, not 2. Train underscore X underscore train, X underscore test, Y underscore train, Y underscore test. It splits both X and Y at the same time and keeps each X row matched to its correctly Y label during the split. No shuffling X and Y independently, that would break the pairing. Okay, I'm gonna just go ahead and grab that. There we go. Okay, test underscore split equal to 0.2. This means 20% of the data goes into the test chunk, 80% into the train. You'll commonly see the 0.2 or 0.25 used as defaults in practice. Random underscore state equals to 42. You've seen this exact parameter before in random forest, same job here. It seeds the randomness, so the split is reproducible. Same split every time you return it instead of a new random split each run. Quick question before you touch the code. Given test underscore size equals to 0.2 on your 8 row data set above, how many rows should end up in test X and how many in X underscore train? Wait a minute, hold on. It splits both X and Y at the same time and keeps each row X. I just realized something. There we go. And keeps each X row matched to its correctly Y label during the split. Okay, during its split, no shuffling X. Test underscore size equals to 0.2. This means 20% of the data goes into the test chunk. 20% of the data goes into the test chunk, 80% goes into the train chunk. Test size equals to 0. Oh, okay. You'll commonly see 0.2 or 0.25 used as default in practice. Random underscore state equals to 42. You've seen this exact parameter before. I have in random forest. Same job here. It sends the randomness to the split. So the split is reproducible. Oh, yeah. Even if I close my exit my output and I rerun, I'm going to get the exact same output. Same split every time you rerun it instead of a new random split each time. Quick question before you touch the code. Given test underscore size equals 0.2 on our 8 row data set above, how many rows should end up on, and how many on train? So 20% on test, and let's go with something like 80% on train. Okay, and then let's just go ahead and send it. You gave me the percentage back. I need the actual row counts are for specific data sets. That's the whole point of a prediction. What do you mean by rows? Wait. Do the math. How many rows is 20% of 8? I do not know. How do we find that out? And what is the purpose of doing so? There we go, and then I'm just gonna add a question mark and send it. Okay, good, honest flag. Let's slow down all the way on this, one step at a time. Purpose first, since you asked before you ever run the code, you should be able to predict what to shape the output should be. Okay, and that's time. Hands off anything that is not distracting. I'm gonna grab Wuthering Waves here real quick because I'm gonna be playing some Wuthering Waves in my free time. Where last stream I did stop at find a way to turn the electricity on. Interesting. I'm just gonna get this a little bit lower. There we go. Just so it doesn't get in the way. Now, apparently to turn the... Okay, I was going somewhere with Alto and Encore, right? So I need to find a way to turn the electricity on. Oh, I need to go there. There we go. Okay, and then apparently I gotta click E. And then find a way... Okay, so H. Induction cell... and cell socket. Use levitator to pull include cells. Okay, you know what? That's fine. Should I talk to Encore?
Cosmos? Cloudy? You saw anything fun?
Okay, I'm just making sure you guys can actually hear it.
Report it in! Cosmos saw nothing. Cloudy saw nothing either. Bah! What? Go! Go look again!
Oh, okay. So wait, D? Wait. Do I need to like put this somewhere? No? I think I should do some... Should I need to... Am I expected to do something with the generator here? Okay, where did that stuff go? Find a way to turn the electricity on. How do I turn the electricity on? Wait, what is this? I don't want to investigate here. And why is it so dark? Okay, so... Oh, I see. Is that trying to tell me to go somewhere? Oh god, I can't fly with this stuff. Oh, so it's telling me to go outside? Is this what it's saying? And then F. There we go. Wait. It says healing. Oh, wow, I healed. Find a way to turn the electricity on. Should I throw it here? Oh, God. Wait a minute. What did I just do? Okay, where do I turn the electricity on from? Should I speak to Alto? Okay, where did I get this from? It should be somewhere here. The place to on the electricity. Wait, it says me to throw it here. Oh, there we go. I need one more for this side. Okay, where's the other one? Do I not? Oh, there we go. I gotta throw one in this side. Did that do so? Oh. Oh, trying to grab it. There. I'm gonna get close to this edge. No? Do I need like a different one? Oh, I should probably throw it here. And then we grab this one. We throw one there. Did I just... Wait. Okay, so apparently we investigate here.
That Fraxidus Overseer has been really generous with his sponsorship. It would have taken us much longer to build this place without him.
I see.
Though he loves to meddle with our experiments a bit too much. Well, he's our patron. Can't do anything about that. This lab's location is a bit too remote for me. But I'm okay with it, as long as we can keep doing our research.
Hologram of a male researcher.
Where else could us maniacs possibly go?
The committee kicked us out like trash. They'll never understand. As Professor Hysen stated, we are embarking on a monumental endeavor with the power to redefine humanity's future. This time, we will make the divine miracle we saw happen again for all of humanity to behold.
Alright. We talk to another hologram, assuming? Oh yeah, we do. Okay, well, that's time. Hands up anything that is distracting. Moving on, back to work. Let me grab Claude here. Let me get this here. Alright, back to work. Okay, so I was reading this, right? I do not know how to find the purpose. Okay. Purpose first, since you asked before you ever run the code, you should be able to predict what shape the output should be if you ran train_test_split and expect 2 test rows, but somehow get 5. That's an immediate red flag that something's wrong. Test_size, or you pass the wrong data set or something. You can't catch that mistake unless you already know what correct looks like beforehand. That's the whole predict before running habit you've been building this entire series. Now, the math. One step, nothing else yet. 20% of 8 means take 8 and find 20% of it. What is 20% of 8? 20% as a decimal is 0.2, so the calculation is 8 times 0.20. Let me grab a calculator out here. What are you doing? Today I am working under the final category under my math and machine learning is phase 2, where I'm currently working with model evaluation and I'm learning about the train_test_split function. Okay, so we're gonna go with something like 8 multiplied by 0.20. So 1.6. 1.6. Correct, 8 multiplied by 0.20 equals to 1.6. Now here's the real world wrinkle worth naming explicitly. You can't have 1.6 of a row. Data doesn't split into fractions of a row. The whole rows are nothing. Its whole rows are nothing. So skit-learn rounds that to the nearest whole number behind the scene. 1.6 rounds up to 2. So test score equals to 2. Now do the same move for train, but this time you don't need to even multiply again. You already know the total of... You already know the total is 8. And you already know the test... You already know test took 2. What's the fastest way to get the train count from here? I do not know. Oh, interesting. Total rows split into 2 chunks. That's it. The whole data set gets divided between them if the test took 2 and the total is 8. That's the left. What's the leftover for train? 6? Correct. 6 for train, 2 for test. Oh! Okay, so our total rows is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, we do have total of 8 rows. And then we want to train. Our train is going to be 0.2, which is 20% of our rows. So 20% of 8 is 1.6, which gets rounded up to 2. And then we have 2 rows, right? We go with 2 rows. So 2 minus 8 is 6. 6 for train, 2 for test. Now, one more prediction before you write and run this yourself. Look at the data set. With random underscore state equals to 42, locking in a specific reproducible split, you obviously can predict which exact 2 rows land in the test without running it. That's fine, that's expected. You have no way to reason that out in advance, but here's what you can reason about. Whatever 2 rows end up in the test will their corresponding labels in the test still be correctly matched to them. Example, if x underscore test grabs the row with 9, will y underscore test definitely have fail in the same position? Why or why not? Based on what I told you about how train underscore test underscore split handles x and y together. If x underscore test grabs the row with 9, will y underscore test definitely have fail? There's 8. Oh, okay, in the same position, why or why not? Based on what I told you about train underscore test underscore split handles x and y together. I think that I need a better explanation for this topic, since it is hard to understand and answer your questions. Maybe an explanation followed by an example. There we go, and then I'm just gonna go ahead and add a period and let's send it. Fair, you flagged it honestly instead of guessing. That's the right move. Let me give you the direct explanation. Here's the mechanism. Train underscore test underscore split doesn't shuffle x and y independently. It picks a set of 2 positions. It picks a set of row positions, say 0, 3 and 6. And then pulls those same positions from both x and y together as pairs. It's not shuffle x randomly, then separately shuffle y randomly. It's pick which indices go where, then apply that same index, select to both lists at once. Think of it like a deck of index. Think of it like a deck of index cards where each card has 2 sides. One side is the x value, the other side is the y label. When you shuffle and deal the cards, both sides of each card travel together. You never flip just one side. Yeah, one is the training side, one is the testing side of a card. Concrete example using our data. X equals to 9, 12, yada yada, y equals to fail, fails, yada yada. Say the split has to select 2 positions. 0 and 7 for the test set. I'm making these positions up just to illustrate, not the real output of random underscore state equals to 42. Then, x underscore test equals to 990. Because those were at position 0 and 7 in x. Y underscore test equals to fail pass, because those were those positions, okay? Position 0 in x underscore test, 9 and position 0 in y underscore test fail are still describing the same original row. The pairing survived the split even though the row got physically moved into the new list. Now back to the original question with the explanation in hand. If x underscore test ends up containing the whole row at index of 9, Will y underscore test definitely contain fail correctly matched into the same position, same original pairing? Why or why not? Back to the original question. With the explanation, if x underscore test ends up containing the row 9, that oh, the row 9. I thought the ninth index. So will y definitely contain fail correctly matched to the same position? Yes, it will. Because wait, let's go with the comma after yes. Yes, it will. Because the data set and the predictions go hand in hand. Okay, because the data set and the predictions go hand in hand. They will always correspond to each other. Okay, and then I'm gonna fix my correspond here and let's send it. Correct and good instinct, generalizing it to data set and predictions go hand in hand. Let's tighten the language slightly though, because precision matters here. Y is in prediction. Y is in prediction is the real true label answer that already existed before anything. Predictions is the world for that, for what the model outputs later after training, where you ask it to guess on new data. Y underscore test is the answer key you grade those predictions against, not a prediction itself. Small distinction, but it matters a lot once we get into confusion matrices. Next, where you'll be comparing real y underscore test against models is predicted y. Interesting. Hold on. Small distinction, but it matters a lot once we get into confusing matrices next, where you'll be comparing real y underscore test against models as predicted y. Side by side, mixing those two up would cause real confusion. Pun intended. Pun intended. Down the line. Alright, you've got the concept, you've got the math, you've got the pairing logic. Time to write real code and check it against real output. Your task in Visual Studio, write a script that imports test/train from sklearns this model underscore selections is file. Use this data set, okay, split it with test underscore size equals to 0.2, random underscore state equals to 42. Print x train, x test, y train, y test. Before you run it, restate your prediction how many rows in x underscore train versus in x underscore test. You already worked this one, then run it, and show me the terminal code. Okay, I'm gonna grab my Visual Studio. Hi, I'm back. Howdy, Philippa here. Appreciate you joining the stream. Okay, and this is the MD file from last stream because I was done with sklearn. And if you guys do want access to all these Python files or my markdown files that I have here, including all my phase 1, phase 2s, I will be uploading them to GitHub. You guys will already have access to my phase 1 in GitHub that consists of a bunch of markdown notes, all the pandas file that I used, all the polders file that I used, all the Python files that I created. You guys can analyze all that stuff if you guys do want it. Everything's going to be in my GitHub. Okay, that said, since this is a brand new topic, I'm going to go ahead and let's say create another folder called, what topic was I under? Model evaluation, right? Model evaluation. So the model hyphen evaluation, EVLUAT. Wait, EVLUATION, EVLUATION. Hey, when did you get glasses? These aren't real glasses, actually. Hold on, let me show it to you guys real quick. But firstly, under model underscore evaluation, I'm gonna go ahead and create a file. What category are we under? Train underscore test, right? Okay, so hold on. I'm gonna create a file called train underscore test underscore split dot py. There we go. Okay, perfect. And then I'm just gonna go ahead and close this. Now about the question, where did I get these glasses from? Let me go to my main camera. These are actually blue light filter glasses. They do not have lens or any kind of I forgot the name for it. What are those lenses called? It does not have any kind of I forgot, zoom in lens or something that makes people see stuff clear. It's just because I got like 3 lights here plus 2 screens flashing in my eyes. In case you guys did not really know, when I am not streaming, this is the kind of brightness that I really do use when it comes to me regularly working. Matter of fact, I go with even darker brightness. This is something ideal because I'm gawking at this screen literally every single day for like really long time. But then when I'm streaming, I just close my filter. Okay, that said, I'm gonna go ahead and read Claude's instruction. So first things first, we're gonna go ahead and import something from our sklearns' model underscore selections' library. So from sklearn dot model underscore selection, I want to go ahead and import, let's say, train underscore test underscore split. There we go. And then I'm gonna go ahead and let's say use a data set. I will not be typing this data set out because Claude really gave me an. In the future, I highly doubt we're ever gonna have to manually type our own data set out because we can literally just get access to it from the place where we really want to get access to our data from. Once we're done with that, I'm gonna go ahead and create a variable called model that is going to be equal to our train underscore test underscore split, which is going to be requiring a parameter of test underscore size that is going to be equal to 0.2. I want my testing to be 20% of what my training actually will be. And then I want to have random underscore state equals to 42. This is going to make sure that my output is reproducible every time I run my program and that it won't be unpredictable. After that, splits it with test underscore size and prints x. Okay, this is the one part that I don't really remember. Hold on, let me grab Claude back up here. This is the one part that I can't remember. So apparently, this is how we split it. Oh, we create 4 variables. We don't create 1 variable. We create 4 variables. Okay, so I'm gonna go all the way down. There we go. Okay, no wonder I was confused. What variable should I have here? Let's go with x underscore train. X underscore test. Y underscore train. And y underscore test. Okay, and then we're just gonna go ahead and print them all. So I'm gonna go ahead and print x underscore train. And then let's just go with an empty print statement. And then I'm gonna go ahead and add another print statement. That is gonna be my x underscore test. And then let's go with another print statement. That is gonna be... Oh god, this is so tricky. Y underscore test. And then I'm gonna add an empty print statement. We're gonna go with something like print y underscore train. I don't know if these extra print statements were compulsory, but I'm gonna go ahead and run the program. I'm gonna go with control / to grab my terminal here and change my directory to my current directory of model-evaluation. Change directory, let's go with something like model-evaluation. Oh no, are you kidding me? Are you freaking kidding me? Hold on. I am not stupid enough to type that whole thing out again. There we go. You know, EV LU8. Oh, EV LU8TION. Oh my god. There we go. Okay, and then I'm gonna manually run my files, so we're gonna go with something like py train underscore train train underscore test underscore split dot py. However, before I run the program, I just realized I forgot to add something. I need to add my x and y variables here. There we go. You know, is it going to be cleaner if I did something like this? There we go. That's so much more cleaner. Okay, and then let's hit Control S to save the code, and then I'm going to go ahead and run it. Syntax error. Oh, so we're not allowed to do the syntax. In C++, unlike Python here, we don't have these pesky restrictions, so we're allowed to do it. But Python, we're not. It's taking a while to run, so I'm gonna give it a while to actually run. While it's running, I'm gonna drink some water. Oh wow, wait, hold on. Wrong variable name error. This is gonna be an uppercase Y. There we go. Wait, that's gonna be an uppercase Y. Control S to save the code. Let's run this again, and this time it should actually evaluate and run. There we go. So, my train underscore x trained with 9, 90, 18, 25, 21, 49, 90, 18, 25, 21, and 40. And then x tested with 2 of those. Why didn't it train with more models? Okay, and then 12 and 30. Why didn't it just get 12 and 30? Is it all random? 12 is a fail, 30 is a pass. Fail, pass, fail, pass, fail, pass. It fails, it passes, it fails, it passes, it fails, it passes. That's correct. Okay, I got this output, but I don't know why didn't it not. So it used 1, 2, 3, 4, 5, 6. It used, oh, okay, you know what? It makes sense. It makes sense because 9, 90, 18, 25, 21, 40, 12, 30. In total, if I were to count my train and test, both are here. This is the math calculation that we did as well. So apparently the calculation that we actually did do was that our total number of our total count of our data set, which is 8 in total, because there are 8 lists inside of my datasets list here. And since my test underscore size was 2, that can be counted as 20%. So 20% of all my data set, which is 8, is going to give me 1.6. So that is basically sklearn is going to round it up to the nearest whole number, which is 2, because 1.6 is almost 2 if we round it up. Okay, and then after we round our number up, to find our test, we subtract our train by whatever number did we get. Whatever number is the 20% of our data set, which here 0.2 is basically 20%. So we just subtract our 8 with our test, that is 2. That gives us 6. So my train is 6. Test is 2 because it's 2 items. Fail, pass. Fail, pass, fail, pass. Yeah, it's correct. Okay. Let's copy this. I'm gonna grab Claude here and then we're gonna paste it. Okay, wait, let me say how many rows in train versus test. Okay, so how many rows? So the explanation that I just gave you guys, I'm gonna give it to Claude. Let me try to rephrase it myself. So we have 8 rows. Let's go with something like we have 8 rows, and we get 20% of those rows because we have 8 rows and we get 20% of those rows because our test underscore Was it test underscore split? Hold on, was it test underscore split? Test underscore size, because our test underscore size was equal to 0.2. And then we end up getting 1.6, which is rounded up, up to a 2. We then, I think we use semicolon. We then subtract 8 from 2, which is equal to 6. Therefore, I am expecting 6 train rows and 2 test rows, because our test underscore size was 0.2. 20%. Okay, and then I'm just gonna go ahead and let's say send it. Here's the thing, if this was my genuine explanation, so if there's anything wrong, Claude can just sketch it up for me. Your final number are right, 6 train, 2 test, but one piece of what you wrote on the way there is backwards and it's worth catching before it becomes a habit. You wrote we subtract 8 from 2, that's 8 minus 2. Wait, actually let's check, you wrote subtract 8 from 2 but then got 6, which is actually 8 minus 2. Not 2 minus 8, so the arithmetic you did was right, it's just the phrase subtract 8 from 2. Oh, subtract 2 from 8. Okay, and that's it, that's time. Hands up anything that is distracting. Moving on, back to Wuthering Waves. I was going to search the room for clues, right? So let's talk to this. Let's investigate this guy.
The experiments have been going smoothly, but we still can't get the desired outcome. Why?
I'm gonna get this clock down here.
The artificial retroactive rain project has advanced to its second phase. We have various evidence that this ancient civilization was the Whining Aches' Maya at some point. We believed we could recreate that divine miracle with the artificial retroact rain. Have we been mistaken? We have no time left. The artificial controllable tacit field should be complete by now. We'll have to rely on our backup plan.
Okay, find a way to turn on the electricity. So I just dropped this here. I know there's
Cosmos? Cloudy?
I just spoke to Encore. I'm gonna click T. Wait, I need that. There we go. Okay, I need to throw this, let's say in this other one. Right here. There we go. No. Wait, I thought that I need to like... It says that I need to throw it. Where do I turn the electricity on then? I opened that one door. Is there any other doors here? Wait, is there... Did I see something right here? Where do I turn the electricity on from? Wait, what's happening? Oh, I see another door there. Wait, did I drop my... Oh, come on. There we go. It's too dark. I can't see squat. There we go. Oh. There we go. H to view the transducer. The transducer. Use levitator to pull the induction cells into the induction cell charger to charge the operating mode of the induction cell and charge the current color of induction cell. So I gotta find induction cells. Wow, 1 asteroid from that. Are there any induction cells here, or do I need to talk to them? It doesn't seem me to talk to them. There we go. Wait, that went... Oh, I see. Okay, wait. What if I hit T? I throw it back. Okay, that is for that. I need one for here. There should be another key thing here, right? It's always been like this. There has to be one here. Unless there's something here. Can I throw this on this side? No? Alright, okay. How do I turn the electricity on now? Genuinely, it's getting too dark here to see. This is my induction cell. Oh, there we go. Is this... Nope, that is not something we can get. Okay, where is an induction cell? So if I find an induction, is it this? No? Do I just hit this? I don't, okay. Something happens when I stand here. I don't know what happens, but something does happen. Something closed. What closed? Wait, is that the induction cell? It's not. I've opened this so far. How do I close this? Uh-oh, it's getting even darker. Or is it just me?
Let's take
how do you
it
turn...
slow.
At least give me instructions as to how do I turn the electricity on. I don't see squat here. Okay, this place is getting scary. I may have to just dip. I can't dip this in my freaking storyline. Wait, what is that? Is that like a cell phone? Oh, it's just... Okay, well, that's it. That's time. Hands up anything that is distracting. Moving on, back to work. I'm gonna get the clock here. And I don't know how to turn the electricity on. Okay, so your final number are tight. 6 strain, 2 test, okay. Wrong operation. Okay, this is the correct one. Not a big deal, but precise language matters when you're explaining your reasoning to someone else. Worth tightening. Prediction confirmed 6 strain rows. Go write the code, run it yourself, okay. I'm gonna grab my Visual Studio Code out here. We're gonna go with Control C, copy that, grab this, paste it here, go with Shift Enter, and then I'm gonna go here, copy my output. Then let's just paste it. Real output confirms your prediction exactly. 6 rows in train, 2 rows in test. X underscore train has 6 entries, X underscore test has 2. Match checks out. Now let's verify the thing we actually spent the last few messages on, the pairing. Let's check it by hand against your real output. X underscore test equals to 1230. Y underscore test equals to fail, pass. Look back at the original data set and find where 12 and 30 are. Okay, I did do this to confirm everything. It was correct. Does 12's original label match where it shows up for it? Does 30's original label walk through both of them? It does match. Don't assert it. Show me this is exactly the independent verify. Okay, 12 sits at which position in the original? Okay, fine. 0, 1. So 1. And then 0, 1. So 12 is supposed to be fail. 30 is going to be 2, 3, 4, 5. 2, 3, 4, 5. 12 is at index 1, which is a fail, and 30 is at index 5, which is a pass. Okay, there we go. Correct and confirmed against your real output. Y underscore test equals to fail, pass. Position 0 is 12's original label. Fail position is 130's original label, pass. Pairing survived the split perfectly, exactly like we walked through with the index card analogy. This is the real proof, not just theory. You built it, ran it, and independently checked it against the source data yourself. Train/split, done. Real code, real output, real verification, no shortcuts. That's 1 out of 4 in model evaluation closed. Next up, confusion matrices, precision recall, and F1. How you call your score a classification model's prediction? Okay, you know what? Can I get a MD file for the prediction for the train/test split? Okay, just the MD file so I can later on refer to that stuff. MD file summary, model evaluation, first subtopic, okay. There we go. Okay, so we got MD file. I'm gonna go ahead and let's say download this stuff. Okay, and now I'm gonna go ahead and let's say grab my Visual Studio Code out here. I'm gonna go ahead and exit this. And this is basically what I always do when I'm actually done with the topic. Why do I see like a green dot here though? What the hell? Alright, I guess I don't know why I see the green dot, but I'm gonna go under my markdown files as notes. I'm gonna go here. I'm gonna go to my downloads. There we go. In my downloads, we're gonna go ahead and grab this and paste it under there. Okay. Now this is my MD file for model evaluation. And hold on real quick. Let me just go there and just zoom down real quick. There. Okay, so model evaluation, the core problem, we did all that stuff. Now we're gonna work on the next part. Hold on, I'm gonna just go there real quick. We're gonna do that. We're gonna go there. We're gonna do that. There. You guys may think what I'm doing. Hold on. Okay, so overfitting, underfitting, we did work with this. The code, we did have like a simple code here. There we go. Okay, perfect. I'm just gonna grab my chat here up. I'm just gonna grab my chat up here real quick. And then let's go ahead and grab Claude up here real quick. I'm gonna go ahead and just say change my chat. Okay. Did I just say? Okay, back in the days, I used to just say Claude that I'm live. These days, Claude wants a freaking trigger from me. There it is. Let's go. Okay, so we were just done with our train/split. Now we're gonna go ahead and work with our next topic, which is confusion matrices, precision recall, and F1, the actual toolkit for judging a classification model beyond just score went up. Quick check before I reteach anything. Have you ever heard the terms confusion matrix, precision recall, or F1 score before anywhere, even in passing? Answer straight, zero exposure, and full exposure both get taught at the same time. I have never worked with it. Yeah, Claude makes sure to ask me every time I go with something new if I have worked or have not worked with it. Good, clean slate, no half-truths to untangle, direct explanation first like we agreed. The problem we're solving, you already know train_test_split gives you a fair test. The model gets graded on the data it never memorized. But right now, all you have to judge that grade with is accuracy. What percent it gets right? What percent did it get right? Here's the problem with accuracy alone. Imagine you're building a model to detect a rare disease. Out of 100 patients, only 2 actually have it. If your model just predicts healthy for everyone every single time, no thinking, no learning, nothing, it's right 98 times out of 100, 98% accuracy, and the model is completely useless. It has never once caught the disease it was built to catch. That's the trap. Accuracy hides what kind of mistakes the model is making. A confusion matrix and its own downstream matrices, precision recall F1, exists to expose exactly that. Not just how often was it right, but when it was wrong. Wrong in which direction and how bad is that direction for the specific problem. The confusion matrix itself, for a yes/no binary classification problem, if there are only 4 possible outcomes for any single prediction, actually yes, true positive, model said no, false negative, actually no, false positive, model said no, true negative. What is that? What did I just read? 4 boxes, that's the whole matrix. Every single prediction the model ever makes falls into exactly one of these 4. True positive, model said yes, actually yes, correct catch. True negative, model said no, actually no, correct clear. False positive, model said yes, actually no, false alarm. False negative, model said no, actually yes, missed it completely. Go back to the disease example that predict healthy for everyone, model every single. Okay, the predict healthy for everyone model, every single one of the 2 patients becomes a false negative. The model missed the disease both times. Accuracy never told you that. The confusion matrix would show it immediately to sitting right there. And false negative box, comprehension checks in your own word. No need to overthink it if a spam filter predicts an email is spam, but the email was actually a normal email from your friend. Which of the 4 boxes does it land on? FP, which is false positive. There we go. However, I did not understand. What are we working on and why did we learn this? And even if we learned this, even if we need to learn this, can I get an explanation? Actually, can I get an example alongside the explanation? There we go, and then let's just go ahead and send it. Fair question, let me ground this before going further, since you're right to ask why before diving deeper. FP is correct, model said spam, yes, it was actually not spam, no, false positive. Nice clean, no hesitation on that one. Where this fits in the big picture, you just spent the last session learning train_test_split how to fairly split data so model gets graded on stuff it's never seen. That gave you 1 number accuracy. The model got X% right on the test set. The problem is accuracy is a single blurry number that can lie to you. Like the disease example, 98% accuracy while being completely useless. Confusion plus matrix plus precision/recall/F1 are the next layer down. Okay, like the disease example, okay, the problem it actually solves. How to fairly split model gets graded on, it's never seen, that gives you 1 number. Accuracy, the model got X. Okay, the problem is accuracy is a single blurry number that can lie to you, like the disease example, 98% accuracy while being completely useless, okay? Confusion matrix plus precision/recall/F1 are the next layer down. Instead of 1 blurry number, you get to see exactly what kind of mistakes the model is making, and there are tools to score how each kind of mistakes is for your specific situation. This directly feeds model evaluation, which directly feeds project 2, where you build a real predictive model and have to judge it rigorously and write it up like you're presenting to a client. A client will ask how good is it, and just 92% accurate won't cut it if the model is secretly missing every fraud case or every disease case. You need to be able to say which kind of mistake it makes and why that matters. concrete example side by side with the concept spam filters, same one from your question. Say your model checks 10 emails, reality, what they actually are versus what the model predicted. Email 1 spam. Email actually model said box. Email 1 is actually spam, model said spam. True positive. Email 2 said is actually spam, model said spam. True positive. Email 3 is actually a spam, model said not spam. False negative, misreal spam. Email 4 actually is not spam, model said not spam. True negative. Email 5 is actually not spam, model said not spam. It's true negative. Email 6 is not spam, model said spam. False positive. Email 7 is not spam, model said not spam. True negative. Spam, spam, true positive. Not spam, not spam. True negative. Spam, spam, true positive. Is that Genshin Impact? It's Wuthering Waves actually. Okay, count it up. True positive equals to 4. True negative equals to 4. False positive equals to 1. False negative equals to 1. Accuracy is 8 out of 10, 80%, but now you can see the shape of the mistakes too. One real sample email slipped through. False negative. One innocent email got wrongly flagged. False positive. Those are two very different problems with different real-world costs. Missing a spam is annoying. Blurring your friends' email into the spam folder might mean you miss something important. Does seeing it laid out against a real table like that, make the 4 boxes click better? It does. However, where will I ever use it? And how did the test was it test slash train, or what was that? How does the test, how does the train underscore test underscore split actually give me an accuracy percent question mark? Is it the test underscore sample equals to 0.2 that I use to have it be 20% the accuracy that we are talking about? Is that the accuracy that we're talking about, question mark? Okay, good. Both real questions. Let's take them one at a time. Where will I ever use this? Anytime you build a classifier and need to judge if it's actually good, not just for courses, for real work, a concrete case, fraud detection at a bank, missing a real fraud, false negative. Cost the bank money, flagging a legit purchase as a flaw, as a false positive, annoys a customer. Very different cost, and you need the matrix to see which one of your model is bad at. Medical screening, the disease example from earlier. Later in your own roadmap, spam slash content filtering agent safety checks. This is the tool called safe to run. Basically anything where your system always says yes slash no and being wrong has consequences. Model evaluation isn't a side quest, it's the thing that tells you whether project 2 actually works before you hand it to a client. How did train underscore test underscore split give me an accuracy percent? Here's the important correction. Train underscore test underscore split itself never calculated accuracy. It only did one job. Split your data into a train pile and test pile, and a test pile. That's it. It has no idea what correct even means. Walk the actual pipeline with me. Train underscore test underscore split xy test underscore size equals to 0.2. Split your data. Test underscore size equals to 0.2 means Okay, itself never calculated accuracy. It only did one job. Split your data. Okay. Splits your data. Test underscore size means 20% goes to test X and test Y. 80% goes into train X and train Y. This step produces zero accuracy numbers just for piles of data. Model.fit X underscore train X underscore Y underscore train. The model learns patterns from the training pile only. Model.predict X test. The model makes guesses on the test pile the data never saw during training. Something has to compare those guesses against Y underscore test, the real answer you held back to produce a score. That comparison step is what actually generates a numbers like accuracy, and it's also what would generate a confusion matrix precision we call F1. So test underscore size equals to 0.2 controls how many rows end up in that final comparison. It does not calculate the comparison itself. Quick check so I know this landed. Which step in that 4-step list is the one that actually produces accuracy numbers? 1, 2, 3, or 4? Predict the guesses on the pile. Learns patterns. So 1 does not produce accuracy numbers. 2, the model learns patterns from the training pile only. It does not produce accuracy. 3, model predict. The model makes guesses on the test pile, the data it never saw during training. 4, something has to compare those guesses against. The real answer you held back to produce a score. That comparison is what actually generates a number like accuracy. And it's also what would generate a confusion matrix precision. Okay, so step 4, because that is just clearly the answer. However, what is the something that we are talking about here? Okay, and then I'm just gonna go ahead and let's say add a space here and let's send it. Okay, step 4 is right. Good. And I like that you didn't just accept it. You're asking what's actually doing the work in that step. That's the right question. The something is a function, usually accuracy underscore score from sklearn, or a simple comparison function. It's not magic. It's not part of that something is a function, usually accuracy underscore score from sklearn. Okay, that makes sense. Or a similar comparison function. It's not magic. It's not part of the model itself. It's a separate tool. Hold on. Wait a minute. I'm trying to get my lighting a little closer to me. There we go. Okay, so, or a similar function. It's not magic. It's not part of the model itself. It's a separate tool whose entire job is take two lists, the model's guesses and the real answer, and compare them. From sklearn.matrices, import accuracy underscore score. Accuracy equals to accuracy underscore score equals to y underscore test and predictions. Mechanically, all it does is walk both lists side by side, position by position, and count matches. Pass, pass, tick. Fail, fail, tick. True, positive, X. Tick, tick. Accuracy underscore score. Here would return 0.8, 80%, 4 out of 5 compared. That's it, that's the whole trick. It's the same core idea as your confusion underscore matrix boxes from earlier. Same two lists, same position by position comparison. Just accuracy squashes it into something, into one number. Percent matches percent matched, while a confusion matrix keeps the 4 categories separate. True positive, true negative, false positive, false negative, instead of blurring them together. One more untaught piece of syntax before we move forward. Same rules as always. Have you ever seen matrix accuracy score? I have not. Every single damn concept under AI engineering or this roadmap is something that I've never ever worked on. Good, that's something new, and what I gave you about is the full teaching on it, not a preview. Let's make sure it's actually usable, not just to read. Here's the real hands-on task. No code from me, you write it, run it yourself on your machine, same as always from sklearn.matrix. I import accuracy underscore score. Y underscore test equals to pass fail pass pass fail pass. Predictions equals to pass fail fail pass fail fail. Accuracy equals to accuracy underscore score. Y underscore test and predictions. Okay, so one of them is not. We don't have a single data set here. I see how are we later on gonna use this stuff with our test slash train slash split this concept. Before you run it, predict by hand, walk the two lists position by position like I showed you above, count the matches and tell me how many matches what decimal accuracy result prints. So tick tick. So 1 correct, 2 correct, fail, 3 correct, 4 correct, fail. 4 out of the 6 rows are accurate, which lands the accuracy to be how do I freaking get this in percent? If that is like 100%, 80%. I'm gonna add a semicolon and say I am bad at math, so I do not know what is 6% of 2. I literally just did the whole entire math in my mind. I'm gonna grab a calculator and in a bit though, because it's 6 divided by 100 multiplied by 2. That's it, that's time. Hands off anything that is distracting. Moving on, back to work. Back to Wuthering Waves. There we go. How do I get this place to light up or lit up? Find a way to... How the hell does a person turn the electricity on? Do I need to talk with Alto?
Crystal potion, glass barometer, instant noodles, packet of nuts. Nothing too fancy. Oh, wow! A game card that went out of sale decades ago. Lucky me.
Is he slacking off?
Hey, Rover!
Am I working?
How's it going on your end? Found anything good? I've collected some things, but not much. It didn't take us long to solve that puzzle mechanic. Thanks to your help.
I saw something similar before. Brute force wonders.
You didn't seem to be brute forcing it, though. Do you happen to know someone from the Court of Savante? I'm really looking forward to making more deals with you.
Okay, that was a whole lot of nothing. At least I spoke with Alto and Encore. Now I need to figure out how do we get this freaking electricity to turn. Oh my god. Do I do something to that? No. Is there no way to turn the electricity on, or am I just too blind for this puzzle? Let me get the glasses off so I can actually see stuff clearly. I think I need to get this to be open as well, right? So maybe I'm gonna grab that. That closes. We're gonna open this. I need another one. This is the wrong one. This thing, it doesn't open. Wait, this has to. This has got to. Here? Oh! There we go. Wait, this is just a charger, right? Did I charge this? I've charged it. Oh, I see. This is a red one now. Now the red one goes in the red section. There we... Oh? Strange. I think it goes in this one then. That already had one. Okay, which is the red one? Oh my gosh, are you kidding me? Okay, which red one does it go to then? There clearly is a red one here. I need a green one here, right? So I'm gonna go and grab a green one from where else? Maybe the 2 greens from there. Oh, so it's basically a puzzle. There we go. Have I already been here? I don't know if I've already been here, but since there is nothing, I'm gonna go to the other one. I need to turn the electricity on. Let's throw this in this other one. Okay, this is
Now,
something.
This is the last room.
Oh, okay.
Encore, spotted something.
I'll take that. Damn. Okay, that was a whole lot of nothing. I like a lot of stuff when I'm working with my ult. New trophy, Silent Burst. Eat this, get out. So get him, bud.
I got your back.
What's your back?
Embracing change.
Time to go big!
Time to go bang. Oh wow, they are actually getting kind of stronger the more I go.
Come on, need to hit something!
Activate the device on the wall. Alright, okay. So F2 unlock. Wait, is that... Have I solved the electricity? Oh, okay, I need to flip this. I know how to work with this. There we go. Okay, and that's time. Hands up anything that is distracting. Let's move on back to work. I know how to solve this though. I'm gonna solve this after my timer is over again. Okay, so out of the 6 rows are accurate. 4 out of these 6 rows are accurate, which lands the accuracy to be 80%. I am bad. I am bad at math. Therefore, I do not know what is 6% of 2. However, if I use a calculator, let's find 6% of 2. So 6 divided by 100 multiplied by 2. 0.12. I used a calculator and the answer is 0.12, which is 12%. Oh, okay, let's see. Hold on, let's untangle this because 2 different things just got mixed together. Fix the actual comparison. Let's check your counter. Walk it with me, position by position. So pass, pass, fail, pass, pass, fail. Go through each one yourself and tell me how many ticks are there out of 6. 4 ticks out of 6. There are 4 ticks in the and a total row of there are 4 ticks and a total row of 6. Separate the 6% of 2 math doesn't actually belong in this problem. Accuracy is in X of Y. It's just matches divided by total. Example 4 divided by 6. So don't worry about the percent of calculation. It's not part of what we're solving here. Once you recount the matrices above, tell me the fraction as matches divided by 6 and we'll turn that into a decimal together. Okay, so we gotta go with 4 divided by 6, which is 0.66. And 4 divided by 6 equals to 0.66. 666666667. Okay, and then I'm gonna send it, which could be rounded up to like 1 actually. Exactly right. 4 divided by 6 equals to 0.666667, about 66.67, not 80%. 66.67%, not 80%. Good catch redoing it by hand instead of trusting your first pass. Now run the real code and send me the actual terminal output. So we confirm the accuracy underscore score. Okay. So we, from matrix METRICS, we import accuracy underscore score, and we have a test and a prediction. Okay. I will be sort of using this part as a tiny reference. Yo, Hiding Pixel, appreciate you joining the stream. Okay, I'm gonna go ahead and close this, and under my phase 2, which I don't really have anything much, under my model evaluation, I'm gonna go ahead and, why is it green? I'm gonna create another file, and I'm gonna go ahead and call that file accuracies. No, what was the topic that we're working with right now? I forgot. I'm gonna wear my glasses real quick. Hold on. Okay, now what was the topic that we were actually working on today? Wait a minute, hold on, there it is. Okay, so confusion matrices. So I'm gonna go with confusion matrices. Confusion underscore .py. Okay, and in my confusion matrices.py, now I'm gonna go ahead and let's say follow the instructions. So apparently from, I'm gonna go with something like from sklearn dot matrices. From sklearn dot matrices, I want to import accuracy underscore score. There we go, and then we're gonna add a data type. I am gonna copy the data type because I don't really want to type it out. There we go. So we have y-test, which is pass, fail, pass, pass, fail, pass, and then predictions is pass, fail, fail, pass, fail, fail. This is basically me testing. This is the test that I'm using for my model. Hold on, there we go. This is the test that I'm using for my model, while this is what I'm expecting, or no, what I am telling my model to predict, because the prediction is not autonomous for the time being. It is manual. Okay, and then after that, I'm going to create an accuracy variable, ACCURACY, that is going to be equal to my ACCURACY underscore scores this function, which is going to be requiring my y underscore test as a parameter and predictions as a parameter. Is that it? And then I'm just gonna go ahead and print my accuracy. And then I'm gonna need Control S to save the code, go with Control / to grab my terminal here and change my directory to my current directory, which is model-evaluation. Okay, and then we're gonna go ahead and manually run our file. So I'm gonna go with something like py confusion underscore matrices. There we go. Module not found error. sklearn dot matrices. MEO. METRICS. Whoops. My bad. So 0.66666, which is apparently 66.67%. I'm gonna go ahead and let's say copy this. Wait, actually, let's go ahead and copy that. Grab Cloud here. Let's go ahead and paste it here. Shift Enter, go there. I'm gonna go ahead and copy that. And then I'm gonna go back up here and let's go ahead and paste it. There we go. Math 0.66666, a bunch of 6. Dead on with your hand math. That's exactly the confirmation we needed. Accuracy underscore score isn't doing anything mysterious. It literally just matches. Divided by total. Same as you did by hand, you've now got the full mechanical chain closed. Train underscore test underscore splits out data dot fit learns dot predict guesses. Accuracy underscore score compares guesses to real answers, one number. Now let's tie it back to where we started the session. Accuracy alone hides the shape of the mistakes. Look at your own data again. Position 3 pass, position 6 actual pass, predicted fail. Using the 4 boxes from earlier, true positive, true negative, false positive, false negative. If we treat pass as the positive class, the yes we're trying to detect, what box do position 3 and 6 each land in and why? So position 3 is going to be true positive. Is going to be true positive. And wait, 3, right? So we have position 6 predicted fail. So pass, fail, pass, fail. False positive, not true positive. False positive. Because the actual result was pass, but however, the model predicted fail, and the position 6 is false positive because of the same reason as well. And then let's just go ahead and send it. Careful, 2 things to untangle here. First, it's position 6, not position 4. Oh yeah. Whoops. 4 was actually, oh, okay, you know what? There. Not quite. Let's slow down and re-anchor what the 2 words actually mean. Actually, yes. Model says yes. False wait. Actually, yes. Model says yes. Model says no. Model says yes. True positive, false positive. Model says no. False negative, true negative. If something is actually yes and model says yes, it's true positive. If something is actually no, but model says yes, it's false positive. So it's true positive or false positive. The model says yes, and the answer is something else. But if the model said no, but the answer is actually yes, it's false negative or true negative. So the negatives come if model says no, opposite to what the actual answer is. It's positive. The model said yes, opposite of what the actual answer is. The order isn't random. It tells you what the model did, not what was true. The second word, positive/negative, equals to what the model predicted. The first word, true/false, equals to whether that prediction was correct or not. Oh, I see. And that prediction was false, wrong. It has nothing to do with the actual answer being positive. Now back to position 3. Actual pass, model predicted fail. So it's gonna be false. So it's gonna be true negative. Okay, model predicted negative. Okay, and then we're just gonna send it. Right, model predicted negative, fail, now finish it. What prediction correct, wrong? Correct or wrong, actual was pass, model said fail. So true or false and positive or negative, actual was pass, model said fail. If actual was pass, model said fail. Model says fail, so the second is going to be negative, actual was pass, so it's going to be true negative. Not quite. You've got the second half right. Actual is pass, so true. But the first half is off. Let's isolate it. True or false means what was the prediction correct? Actual equals to pass, model predicted fails. Did the model get it right or did it get it wrong? It got it wrong. Right, it got it wrong, so model predicted negative, fail. That prediction was wrong, false. False plus negative, false negative. I see. I see how this works now. Now apply this exact same two-step process to process yourself. No help this time to position 6. So position 6 actual is pass, model predicted fail. So model did not predict the right thing, so it's going to be false. False, positive. Because the actual answer is true, model predicted wrong. You jump back to guessing the whole label instead, okay. What did the model predict? Positive or negative? Actual is pass, model predicted false. Good. Step 2, was that prediction correct or wrong? Actual, pass. Model said fail. Model had a negative prediction. Negative goes second. So, true negative. The answer is true. Model negative. There we go, and then let's send it. It would be false negative. Opposite cancels each other out, question mark. False negative. You're answering both questions at once. Slow down, just one piece. Actual was pass. The model predicted fail. Did the model get it right or wrong? It got it wrong. Good, so wrong predicted negative, and that was false. Good. Wrong, so predict negative, so predicted negative, and that was false. Oh. Oh. Can I get another question? I see. Okay, you know what I think I see? Okay, so next one, fresh work. So actual is false. Model predicted pass. Step 1, what did the model predict? Positive or negative? Model predicted positive. False positive. Slow down, you're skipping 2-step again. The model predicted pass. Is it positive or negative? What's good, by the way? You're hiding Formidable Thunder. Appreciate you joining the stream. I am actually, let's see, working with, I keep forgetting, Confusion Matrices. There we go, which is actually confusing the heck out of my mind right now. Good. Positive. Actual was fail. Model predicted pass. Was the prediction wrong? It was wrong. It was wrong. So, negative. Wait, you're mixing up the two steps together. Wrong belongs to step 2. Negative was already answered in step 1. Was the model's prediction correct or was it wrong? I've once again become obsessed with the lore of Dragon Ball. That actually sounds really cool. So false positive. I said false positive. Okay, correct answer. Quick gut check before moving on your own words. What's the difference between false positive and false negative? Not the definition, the real world difference. So false positive is when the model predicted true pass. However, the actual answer was fail. So the model okay, let's go with something like the model predicted a false. Model predicted a false positive. Oh god. There we go. And false negative. False negative is when the model predicted fail. However, the actual answer was pass. The model predicted a false negative. There we go. And then I'm just going to go ahead and send it. Have you planned to watch/rewatch all these series, movies, and OVAs? Good luck with that. Sounds kind of cool. I remember you said you read the manga. Do you have physical? Yeah, I do have physical. And the manga of which series? Just Super? Yeah, I just have the Super series with the Moro arc, and when everyone went to the galactic place, they fought Moro, and also with the Granola arc, but I don't want to have any spoilers for that. I do not have a specific Frieza's arc yet. If you did read all the mangas online, you would know the Frieza, but I'm not gonna say it out loud. Okay, that's accurately mechanical. You've got the definition locked. But notice what you just did. You restated the rule of how to identify each block. Not the real world difference. What actually goes wrong for someone when each one happens? Let's ground it back from your own spam filter example from earlier. False positive in spam filtering equals to your friend's real email gets thrown in spam. You might miss something important, but the email is still sitting there findable. False negative in spam equals to a real spam/scam email sent straight to your inbox undetected. Which of those feels like the worst mistake to you for a spam filter specifically, and why? Your friend's real email gets thrown in the spam. My friend's real email gets thrown into spam. That's a real answer, but I want to push it a bit, not because it is wrong. There is no wrong answer here, but let's stress test your reasoning. Think about what actually happens in each case. False positive, friend's email, spam folder, annoying, but the email still exists. It's still sitting in your spam folder. You could still find it if you go looking or catch it eventually. False negative, real scam email. Lands in your inbox undetected. The filter's entire job was to catch this, and it didn't. Now a scam email is sitting in your inbox looking legitimate, waiting for you to click something. Given that, does a missed scam slash physics PHIS sizing email sitting undetected feel more dangerous? It does. Okay, funny how certain characters are named after food. Example, Gallic, Penny, Granola. Actually, I haven't thought of it that way. But let's see, I don't really want to talk much about the arc or the characters in chat because I don't really want it to be a spoiler because, you know, those character names are... I mean, I don't think character names itself could be spoilers. Maybe it could, to be honest. Okay, good, and that's real definition. Okay, and that's the real point of this whole session. The worst mistakes isn't fixed. It depends on the situation. For a spam filter, missing a scam. False negative is usually worse than a false alarm. False positive because... Okay, well, that's time. I'm gonna move on back to Wuthering Waves. Alright, so we were actually, trying to figure this puzzle out, which is pretty easy because I've done it once. I'm gonna rotate it. Switch it again. Rotate it. Rotate it again and again. There we go, that should open it. Okay, I recently learned Majin Buu was actually millions of years old. Oh, actually, yeah, in the...
will be my final words.
They did say that, they did mention that stuff.
If only I had more.
Okay, I'm gonna go here. And something else, there's something else funnier from Majin Buu as well. I could talk about that in the Discord server, but if I create a spoilers channel, which I probably will.
I thought my enemies were misconceptions, waning passion, and my own ignorance. Only in the end did I realize time is my ultimate foe.
Elder male
I
voice.
became blindsided by my fear of death and insatiable thirst for truth, eventually derailing our research. It was too late when I finally came back to my senses. We had already walked into that false gate. Now, I'm leaving my last realization behind. They are our past. But they are also our future. Had I realized it
why is he
sooner,
echoing?
there might have been a chance to get things back on track.
Yeah, we could DM as well. Or I could probably create a... Because I was planning to create a channel for spoilers, because in general, people would like to talk about spoilers in the anime
hailing
chat.
from our past. Please save us once again. Please keep pushing forward until you reach the real gate that can change the world.
Wait, is she a sentinel? Or... blurry female hologram.
Wow! She's so pretty!
Rover, about this person.
I think I know her, but I can't remember why.
Knew it.
Knew it? Wait, Rover's like a bajillion years older, right? So...
Great. Now that power's been restored, the elevator should work.
I mean, I don't think I'm spoiling because I'm saying... because what I'm saying is ambiguous. That does make sense, but I feel like there are so many times where I get too carried away with these conversations. I just blab everything out. So that's not that good.
The beacon signal is coming from below. Let's go.
Okay. Let's see. So, take the elevator to the basement. Oh, where's the elevator? Oh, I did turn the light. Okay, I gotta go there. Oh? Right here? Oh, this is the elevator. Where is the... Oh, can I open this? Free freebies?
You tunes like this stuff, huh?
20 asterisk. Hey, appreciated, but...
Come on!
Where
need
is
to
the
hit
elevator?
something.
This character named nothing that happened in the story. Need to see. Where's the elevator? It keeps... It's below me. I need to somehow find a way to go below me. How do I go below me? What the hell? Finding these things takes like 10 years.
Come on! Need to hit something!
Where is the elevator? Is it in one of the rooms? I think it should be in one of the rooms. I'm gonna go to the other room. I wish I could use my motorbike, which I cannot apparently. Wow, all the gates have been closed. One way to find out where to go. I came back to where I started with.
Come on! Need to hit something!
Take the elevator to the basement. Okay, is this the elevator? Oh, there, this is the elevator. Oh, there. Okay, I'm gonna go to the basement from here. I also don't know if I should watch original Dragon Ball Z and Dragon Ball Kai. I would highly recommend you watch it. They're like the OGs. That's like really fun to watch. Even though the quality isn't that good. Heard Kai is just the same story but higher quality animation and much less filler. I mean, I think it's kind of fun, like, you know, even though some people don't really like watching fillers, for some reason I kind of enjoyed it. Only for Dragon Ball Z though. A big chunky monster.
Damn! Those savants never run out of new surprises for us. The signal's coming from it. Did it swallow our resonance beacon? Looks like peace isn't an option. Guys, brace yourself. We'll need to take it down.
We're gonna fight a monster here. Let's go.
Alto, we doing it like we usually do?
Of course.
Is Alto and Encore
Then
gonna
this
fight?
big guy is Encore's to tackle.
Wait.
Cosmos, Cloudy, attack!
Let me figure out its weakness.
Wait. Oh god, I'm fighting as Encore.
So much fun!
This is so much fun. Nah, I'd rather use Rebecca. She's so much cooler.
Cobbled together from these metal parts. We should target its joints. Use the fallen parts to counter its attacks and destroy its unstable structure.
How the heck am I missing? How the hell did I miss every damn thing that I shot?
Get
Yeah, it's lost.
Here we go again!
Everyone stand down. Attack is the best defense.
Attack is the best defense. Wow, he's got a hell of a lot of HP. Maybe I should break his shield first? Something like that, I think.
Embracing change.
Racing change.
Eat that! Shut your sticky pie hole! Go get him, bud!
There we go!
Come on! Eat less! Slow down!
Eat lead! Oh no, I didn't have stamina!
Release attack!
Okay, I'm gonna run away. I wanna see Encore's special ability. I'm gonna recover. There we go.
You're in for it now!
Okay.
Here comes on lightning!
That's it? Oh shoot, Rebecca's dead. Wait, I may actually lose. I'm so used to being freaking invincible.
An oversight. Tranquility shines. Embracing change.
Embracing change. How the hell is Encore like a bajillion stronger than my strongest units here? Hey, that was a strong ass shot.
This is so much fun!
I should have only used Encore to be honest. Yep. Itch while he's down.
Embracing change.
Wait, she heals our enemy. She heals my allies? I didn't know she's that good. Yeah, I need to recover some. Let me heal some. Dragon Ball Z is 290 episodes. I brings that down to
Unacceptable
168.
damage. Embracing change.
I got your back. Attack is the best defense.
That is the best defense. Hold on, I'm gonna read the comment in a bit. Let me just move on. Wait, does Encore actually buff us?
Get warmed up!
Just getting warmed up. Am I missing every damn thing?
There, goodbye!
He didn't take squat for damage, by the way.
Into Wooly's belly you go! This is so much fun!
Oh wow.
Phew! Job done.
Anka is strong! Told ya!
She is strong. Wonder if she's gonna be in the gacha next. Even that one summoned for her, but still, she was pretty strong.
But why did they keep that big guy here?
Okay, now Dragon Ball Z is 290 episodes. IIRC and Kai brings that down to 168. I see. I guess even though watching both might be repetitive, it may still be unique. It actually would. Seeing how fights and stuff are done between them, that actually does make sense.
According to our findings earlier, researchers who worked here were probably only a small faction of the Corte Savante Committee. They were likely studying an ancient civilization they deemed to be divine beings, but later got denounced from the CSC due to their extreme methods. Somehow, they believed this ancient civilization had once visited the Mire, which led to their attempts at recreating those past events with artificial retroact rain. And when they failed to recreate the retroact rain, they resorted to making a replica of the lost civilization instead. To get their desired results faster, they started feeding this replica various frequencies, data sets, and mechanical constructs. And we've seen what that ended up with. It turned into a monster, driven by the frequencies of hunger, devouring everything in its path.
I see.
It was probably the culprit behind the disappearance of those folks. And I suspect the Fraxidus Overseer mentioned in that log may have something to do with it all. Those researchers, they were too obsessed with validating the divine miracle they experienced. They eventually got lured into the monster's frequencies of hunger and willingly walked into its maw. The monster devoured them, but not with its teeth. Their own delusions and fear were their undoing in the end. What a crazy bunch. So, Rover, now it's time for me to fulfill my promise.
I think that was the first time I've seen Alto talk in a serious tone.
What do you want to know about the Black Shores?
What on earth does the Black Shore do? Have you been stalking me? Do you know a person named Camellia? What are you doing in Jinzhou? What is the relationship between me and the Black Shores?
I'm just an insignificant consultant at the Black Shores, so I don't know that much about all its hidden secrets. But I believe the piece of intel I'm about to share with you will make this trip worth your effort. This is not the first time you've been reawakened.
Oh?
Last time, you woke up at the Black Shores. Rover, we share the same goal. We're both aiming to fight against the Threnodians and prevent the Lament Crisis.
Yep! Onkar can prove it! The Threnodian is a bad, bad bad guy, and Encore and Alto are the heroes of justice. So we're gonna stop the bad guys.
I understand. Trust isn't something you could afford to give out that easily. Remember the Blake bloom I gave you earlier? It's more than just a symbol. It also holds the key to our headquarters. I'm sure it'll come in handy for you.
Oh?
Phew. Anyway, mission accomplished. We've got the resonance beacon secured, plus a sweet bonus of Cortus Savante's big secrets. Glad I got you on board, Rover. Looking forward to our future collaborations. Oops, almost forgot. Gotta check the resonance beacon again, just in case. Wait, this is... No, it can't be.
What's up?
Hey, Alto! Wait!
Did he just dip? He did just dip. Oh wow, 100 asteroids. Let's go. Quest complete. Let's go. Let's go. Meet with Alto and Encore. 78 meters. I'm getting a bunch of things. But hey, I'm gonna... Oh wow. Oh wow, they're high up. I think I gotta use the elevator, right? Right? Nope, I'm lost. Well, actually, I'm not really lost. I could really, like, climb this thing up. But I will be trying to figure this out later on. Maybe next stream. Is this the elevator? Oh, it is. Okay, perfect. That is, like, pretty much it for this. I'm gonna open the shop real quick because I want to see my events. Wait, is this something new? Redeem... Is that like a hamster? Nice. Wait, can I redeem again? Is there no limit? Wait, there's astrikes in there? Redeem Lolo stamps again? Is it too much to ask? Okay, and that's time. If you guys are continuing this stuff, you guys can get your hands off anything that is distracting, but I will be completing some of this stuff and then just closing the stream. Maybe I'm gonna end the stream in the next minute or so, because I am pretty much done with everything here. Yup, there's nothing good here. I would have gone to the convene, but let's be honest, there's nothing good. There's not going to be anything to the convene either.
Why hesitate if you know what you...
Perfect weather for a walk today.
There's just... I want to kind of ascend my characters up.
Maybe not.
If there's someone who I want to ascend, it's definitely going to be Rebecca. I may go on a quest for these later on. Okay, but that's it. That's pretty much it right now. I'm just gonna go ahead and let's say exit this, grab my OBS, and move on to a main camera. There we go. Alright guys, so basically that was pretty much it for the stream. If you guys did enjoy the stream, don't forget to smash the like button, subscribe and notifications turn on. And if you guys did enjoy my content /videos /live streams in general, make sure to share my channel because like helps my algorithm share and makes you smile, and subscribe and then get on top. That said, if you guys do want to follow me in any of my socials, you guys can get access to all my socials through the link in the description, which is gonna be right here. Through my, let's say, bios, which is gonna be here. There are all my socials. Or by typing exclamation and the name of any of my socials in chat. For example, exclamation Discord can get the Discord server. Exclamation Instagram can get Instagram. But it all needs to be all lowercase and no space. That said, if you guys... do want to, I did create 2 brand new channels. If you guys do want to follow me in either one of those channels, which were one of the channels that I created is called Viv Arcade and the other is called Viv Works Out. Viv Arcade is specifically meant for my gaming content and Viv Works Out is specifically meant for my workout content. You guys can get access to both those channels through my homepage. If you guys scroll all the way down, I have both those channels here. Where in Viv Arcade, I do specifically upload gaming content, and if it works out where I haven't uploaded much today, but today a video should upload is based on my workout content. And yeah, that was pretty much it. And if you guys do want access to, or if you guys do want to follow me in my AI Engineering for 365 Days series, and that you guys want access to the roadmap that I am currently using for this series, you guys can get access to that roadmap through my Discord server. If you guys join the Discord server, either go to the Coding Helps Us chat, the general chat, or the Python chat, mention my name there, asking me for the roadmap. I will be personally DMing it to you guys as soon as the stream is over. And that was pretty much it. You guys can get access to my Discord server through the link in the description, through my bio, or by tapping exclamation Discord on chat, all lowercase, no space. That said, I'll catch you guys next live stream or video. Peace. Okay, I guess let's end this.